Yeah, next is the discovery of proton.
Sir,
Yes, tell me.
so can you please explain Millikan's oil drop experiment again?
Yeah. Okay, fine. Yeah, now I'm going to that only. Nickel, I'll see this.
Okay, sir.
Yesterday you draw the diagram. Yesterday, last class.
Yes, sir.
So it is the diagram is like this, right? A minute. This is the one. Yeah, this diagram. So same, this is one electrode plate. In this electrode plate, small hole is there. This is the small hole, right? These are the oil drops. Oil drops are spread by. So here one atometer is there. Atometer means this is the oil drop. Drop diagram already drawn diagram, right? So this is the oil. Oil is spreading inside. This is the mist of the oil drops. These are the oil drops, right? So here one electrode plate is there. Okay, here one electrode plate is there. And here you can observe that is a one microscope is there. You can to observe the what happens inside. This is the microscope. But here oil drop, one drop is coming to this through small hole, one drop is coming. So in this between these two electrodes, this is one electrode, this is the electrode, positive electrode, this is the positive electrode, this is the negative electrode. In this between one drop is there. It now chargeless only. So when it is X-rays, some X-ray source ionized diffusion, that means ionized radiation. So actually this we are sending one radiation. This is X-ray source, and we are sending from here. This is X-ray ionized radiation. The ionized radiation, due to ionized, you know what is the meaning of ionized radiation? Huh? So any air particles or it is ionized. That ionized means charged. That charge is deposited, charge that is deposited on the oil drops. That means when ionized radiation passes into this tube, the neutral oil drops attains charge.
Yes,
right?
Sir.
Then the charge Q is equal to integral multiple of the electron charge. Q is equal to integral multiple of charge of the electron. Already, therefore, the N is equal to Q by E. So what is Q? Quantity of charge on oil drop divided by electron charge. Then we will get the number of electrons in particular oil drop. Suppose the oil drops, different sized oil drops, right? So number of oil drops, different oil drops having different number of electrons. That is calculated by this formula. Oil drop is sometimes it is a large size. It acquires maximum charge now. The maximum charge means Q is maximum by electron charge is constant. So we'll get the number of electrons on particular oil drop. Understood or not?
Yes, sir.
Is there any doubt? Already one problem also I given, right? Based on Q is equal to NE. So an oil drop has 8.0 into 10 power minus 19 coulomb charge. How many electrons does this oil drop? So Q is equal to Ne by N is equal to Q by E. By calculating, we'll get 5 electrons. Got it now? Last class. Any doubt in this? Hello?
No, sir.
No,
Can I
sir.
move? Can I move to another concept?
Yes, sir.
Right. Next, discovery of proton. Discovery of proton. Go for this next discovery of proton. So what is the discovery of proton means? It was discovered by Goldstein. Simply is nothing but anode rays experiment. So what is anode rays experiment? Like a discharge tube only. That electric discharge tube slightly modified. What is the electric discharge tube? Last class I draw the diagram. Again you see this. 1 minute please. So simple diagram series. This is electric discharge tube, right? Electric discharge tube. Here that electrodes, that electrode previous electric discharge tube. Perforated cathode is taken now. Here perforated cathode. What is this is anode, right? Anode plate. Here this area, middle of this, not exactly middle. So perforation means the holes are there. That is perforated cathode. This is reduction. That is already.
Sir, your voice is breaking.
Yeah, see this electric discharge tube rough diagram, and I'm drawing the rough diagram. Try to understand this. Same like electric J.J. Thomson electric discharge tube only. Slightly modification. What is the modification means? This is the anode. This is the anode. Anode means positive charge. So what is the cathode here? Perforated cathode. This is the perforated cathode. Try to understand now. Perforation means, so it is the small holes present in this perforated cathode placed at the not exactly middle of the discharge tube, and this is the source of electricity. This is minus and plus, so around 10,000 volts. So here, what is the hydrogen gas? A lighter gas only generally placed in H gas. So now, by passing electric current, that means when pressure also reduced by vacuum pump. Here vacuum pump is there. This is vacuum pump. Vacuum pump. So here pressure is reduced by, what is the pressure in this case inside of the tube? Around 0.01 mm of Hg. Mm of Hg means it is almost negligible pressure. The pressure is reduced from this tube. So now some radiations are emitted. What radiations are emitted means, from we are discussing about anode rays. That is the anode rays. Anode rays. Try to understand here what I am discussing. In this anode rays,
voice is still breaking.
1 minute. So cathode here, when this charge part hydrogen atoms are there, right? So obviously these anode rays are emitted and touches the neutral atoms. Here electrons are emitted now. That touches the neutral atom, and these gas particles are bombarded to one another and loses their electron. Loses their electron. Loses their electron, it becomes positive ion. But the positive ion, what is the velocity of positive ion or attraction? Positive ions attracted towards anode, negative, cathode plate. So what is the charge in this cathode plate? Negative. So these are charged particles. So that moves towards like this. Moves towards like this means, so their perforation is there. The cathode contains holes, perforate. So some difference is there, how it comes. Right. Here this anode, this is the cathode plate, negative charge. Anode plate is this. So this is the anode. Now electron, not electrons. When pressure is reduced to around 0.11, almost negligible, and by passing electric current around 10,000 volts, then what happens? The electrons are emitted from the cathode and touches the gas particles like hydrogen, lighter atoms. So when this bombarded to one another, the elements, that means hydrogen atoms, releases the electrons. When electrons are released, what happens? It becomes positive, right? The positive ions, then what is the movement of positive ions? Gas particle or ions movement is towards negative. Negative, where is the negative? Electrode, perforated electrode is the negative, right? So these H plus ions or anions, that is moves towards the cathode plate. Cathode plate. So cathode plate has a porous. Porous means pores. Small holes are there and passes out through the perforated cathode, and a green that is a fluorescent screen is placed at the back side of the cathode here. So on this cathode, fluorescence takes place. So that means fluorescence takes place because of the anode rays are passed through the cathode. These are the process to generate the anode rays. Now come to the characteristic properties and we'll discuss. Draw the diagram, that one. Okay, it was discovered by Goldsmith. Points I am writing here, note it down. Yeah, now are you able to listen my voice? So now, okay, that disturbance is created by some of you only. Now I am muted to all. Now are you able to listen my voice? Tell me now. I will explain. Hello, are you able to listen my voice? Respond anybody. Can you listen my voice? Okay, I will explain again. First listen. Voice is, are you able to listen voice? Okay. Now, still breaking. Yeah, I muted all participants. Okay, right. So let us know what is the Goldstein also explained the same electric discharge tube like J.J. Thomson electric discharge tube. Now, slightly modified this electric discharge tube. What is a slight modification of electric discharge tube means? Here, this is the anode. Cathode plate, the perforated cathode is used. Perforated cathode is used and replaced at the not middle. It is on center of the discharging tube. Now, in this discharging tube, taken gas that is a hydrogen lighter weight hydrogen gas. So it is completely vacuumed. Vacuumed means the pressure is reduced by vacuum pump and by passing electric volt this much. Then what is the thing is try to understand this here. So as usual, anode particles. Anode particles means see cathode rays. What happened? Okay, sorry, you can. Okay, okay. Okay, okay. Who is the Osama bin Laden? Uh, Okay, okay. Quite right. Serious. Same, very listen carefully. Easy, it's not difficult. As usual, the from cathode plate, electrons are released and bombarded to the hydrogen gas atom, neutral atom, and their hydrogen ionized. The gas itself it is ionized and becomes a positive ions. The positive ions movement, positive ions look at a negative only. So where the negative, cathode is the negative. So it moves towards a cathode plate and it for us it passes out and focused on the fluorescent screen placed at back side of the perforated cathode plate. So based on that, we can take the observations and the characteristic properties we'll discuss now. So I'm writing, note it down. So protons, anode rays means it's a proton only. The protons discovered by Goldstein. Goldstein. Right. Yeah, try to understand. Next point is so helium. Okay, he used that same electric discharge tube and the properties of anode rays. Now come to the properties of anode rays. So that is the rays are termed as canal rays. Hold on. We used perforated cathode. Perforated cathode node in the discharge tube. Discharge tube and replace J.J. Thomson experiment. J.J. Thomson experiment. And observe the formation of anode rays.
Sir,
Yes.
so he used what cathode, sir? He used perforated cathode.
Perforated.
Perforated.
This
Okay,
is-
okay.
ah,
Okay, sir. Thank you.
and observed the formation of anode rays. Observed the formation of anode rays. I'll say this, it is correct. Okay. Oh, it's difficult. Okay, next point. These rays also termed as the canal rays. These rays are also called as canal rays. The canal rays are simply positively charged gaseous ions. Positively charged gaseous ions. The name proton was suggested by Rutherford to hydrogen nucleus. Next, what is the next point is the name proton is suggested by Rutherford to hydrogen nucleus. Hydrogen nucleus. Yeah, Goldstein only. Man, yeah.
Sir, I didn't understand the second point. Can you explain it?
Hello.
Hello, sir. The second point I didn't understand, sir.
Second point. Yeah, see this. I'm reading the anode rays. Why these are called anode rays? Means the traveling away from the anode. That means emitted, not exactly emitted from the anode plate, but moving towards cathode and generated from towards inside of that region. That's why it is anode rays.
Okay,
The
sir.
proton, yeah. He means Goldstein used the perforated cathode in the discharging tube and replaced J.J. Thomson experiment and observed the formation of anode rays. These rays are also called as canal rays. Canal rays means why these are called canal rays? They passes through the holes. So the canal rays are simply positively charged gaseous ions. So the name proton is suggested by Rutherford hydrogen nuclei. Rutherford to hydrogen nucleus. Now come to the properties of anode rays. Can I clear this page?
Yes, sir.
Come to the properties of Disturbance is coming. Why who are doing like that? I don't know.
So 1 minute, can you go back to the previous page? Okay, sir. Thank you.
Next. Okay, but next properties of anode rays. Properties of anode rays.
Sir, can you copy the previous page? 1 minute.
Yeah, properties of anode rays. Note down all properties. Properties of anode rays. Note down point wise. Anode rays travels in the straight line. Anode rays travels straight lines and these are material particles. These are material particles. These are material particles. Next. Anode rays are positively charged. Positively charged and get deflected by external magnetic field, by external magnetic field and affect the photographic plate. Affect the photographic plate. So next point is the E by M, charge to mass ratio, value of these rays. Is smaller than that of E by M, value of electron. You know why it is smaller means E by M. M value is more. Here proton mass is greater than the electron mass. In denominator is more means obviously it is the small value. The E by M value of anode rays depends upon the nature of the gas. So E by M value is depends on the nature of the gas. Nature of the gas used in tube. So what gas is taken? That is the, so if it's hydrogen gas, hydrogen, helium gas, whatever it is that, because the particles are not emitted from the anode. So the radiations that anode rays are emitted from the gas only, ionized gas, not from the anode plate. And E by M value of anode rays, is maximum when the gas present in the tube is hydrogen. The gas present in the tube is hydrogen. So that value is, take this value here, 9.58 into 10 power 7 coulomb kg in per kg, or 9.58 into 10 power 4 coulomb per gram. Right, that one. Okay. So the protons carry unit positive charge with unit mass. So next point, take this one. The protons carry unit positive charge with unit mass. So finally, last, what is the conclusion is, Rutherford obtained protons by bombarding nitrogen atomic nucleus with alpha particles. So this is a simple reaction. So what is the nitrogen isotope N714, right? Plus alpha particle means helium-24. When alpha particle is bombarded with nitrogen nuclide, it becomes proton is emitted. Proton H11 is the proton, and oxygen 817. This is the proton. Right. Note down these important points in the proton. Next, let us discover. Next, to go for the discovery of neutron. Take this. Who is this? Krisha. What is the problem, Krish? Okay. I'll repeat. I'll go back. Okay. First, note this one. Can I clear? Hello, students. Now, okay, you are able to listen my voice? Vedant? Mute, unmute. ఆన్లైన్ చేశారు. హలో హలో హలో, are you able to listen my voice? Hello students. Okay. So okay. Hello. Oh, okay. Right. Hello. Okay, continue. Note down this one. Discovery of neutron. So neutrons are discovered by James Chadwick when beryllium and boron nuclei are bombarded by alpha particles. The neutrons are formed. It's chargeless and mass particle. That mass is equal to proton mass. They have no charge, but possess the mass almost equal to 1 proton. Not this one. We are going to atomic models. Atomic models. Right. Now I am clearing this. Next, atomic models. Right. Listen now. Next, come to the atomic models. What are the atomic models? There are different atomic models are there. That is Joule-Thomson. That is Thomson atomic model. It is also called as Plum-Pudding model and Rutherford atomic model. Next, Bohr's atomic model. Now we are going to discuss one by one. So try to understand now here. First, what is the first one is the Pudding model or is Thomson model. What is Thomson atomic model? So okay, this Thomson proposed that an atomic atom is a spherical shape with radius approximately. So it is only 4 points are there. Note it down. Thomson atomic model. Thomson atomic model. So what is the Thomson atomic model? Okay, according to Thomson, the atom is in spherical shape with a radius approximately 10 power minus 19 meter, in which the positive charge is uniformly distributed. In which the positive charge uniformly distributed. Uniformly distributed. The electrons are embedded into that. What is this? Next point. The electrons are embedded into the electrons are embedded into it in such a manner as to give more stable electrostatic arrangement. More stable electrostatic arrangement. More stable electrostatic arrangement. This atomic model is also known as watermelon model. It is also known as watermelon.
Melon.
So here, what is the watermelon means? You know watermelon. So when it is
Fruit with
packed
seeds.
inside seeds are one arrangement. It is also called as the plum pudding model. It cannot explain the electrical neutrality of the atom. Next point. It cannot explain the electrical neutrality. Of the atom. Of course, this model also called as a plum pudding or resin pudding model of atom. Same. Next point. This is also known as plum pudding model. So what is this? Say observe this diagram, small rough diagram only. Negative. The total remaining is the positive uniformly distributed. This is a negative. Negative. Try to understand this clear.
So what's the fourth point?
The atom is a spherical shape, radius approximately 10 power minus 19 meters. I'm sorry, 10 power 10 only, not 19, 10 power 10. Next. Now this is the positive
Sir,
charge.
don't go to next page. 1 minute.
The rest part is the positive charge uniformly distributed in this diagram. The rest is the black, different colors.
Sir, fourth point, what is the fifth word?
1, 2, 3, fourth. It cannot explain, cannot, CANNOT, you can write properly. It cannot explain the electrical neutrality of the atom. Electrical neutrality of the atom. This is also known as plum pudding model. Of course, diagram we understood or not. Positive, negative, uniformly distributed. That what I given round shape now inside, that is a negative, and the remaining is the positive charges. Remaining is the positive charges. Here positive, 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 positive. Positive also distributed uniformly. But is the fail to explain the electrical neutrality of the atom. Can I clear this page? Okay. Right. Now, before going to Rutherford, just to write the fundamental particles characteristic properties. What is the atomic mass? Take this one. Fundamental particles table. Name of the particle. Take this one. Name of the particle. Mass. Relative mass. Okay, mass and charge. Take now here electron. Electron symbol is N. Electron E, small e. Proton, that is P. Neutron, That is N. Take the mass of the electron is 9.1 into 10 power minus 31 kg, or 9.1 into 10 power minus 28 grams. Charge, what is the charge? 1.602 into 10 power minus 19 coulombs. So that is the charge, or minus 4.8 into 10 power minus 10 ESU, electrostatic units. This is the electron. Next, proton. What is the mass of the proton? Mass of the proton is 1.67.
Sir,
8
what is that? 9.1 into 10 to the power minus 31?
kg.
Okay.
Or in the proton mass is 1.678 into 10 power minus 27 kg. So what is the charge? Almost it's a positive charge, plus 1.602 into 10 power minus 19 coulombs. But in ESU, electrostatic is same, 1 point plus 1, 4.8 into 10 power minus 10 ESU, electrostatic units. Coulombs is the SA system and ESU is the CCS system. Next, what is the mass of the neutron? It is slightly greater than proton. So here 1.67. Okay, actually this is 3 only. 1.673 here, 1.678 into 10 power minus 27 kg. Or what is the mass? Charge is 0. Charge is 0. Note this values.
Sir, wait 5 minutes, sir.
Okay, completed. Huh?
No. 5 minutes, sir.
Okay, 3 values you are asking, 5 minutes.
Okay, sir. Erase.
Yeah, next. Now we are going to discuss the Rutherford atomic model. Come to.
So what was the charge of neutron?
What one?
Charge of neutron.
0.
Charge of neutron now 0. It is a neutral now.
Oh, okay, sir. Okay.
Next, Rutherford atomic model. So actual real chapter is from here only, but what I discuss is the fundamental particles. So sometimes they may or may not ask the questions, rarely asked. But here, real from important part, even CBSE or whatever it is. So now Rutherford atomic model, listen all of you. So this atomic model, so So here one experiment is there. Here, what is that experiment? Scattering experiment. Alpha rays scattering experiment. Writing, you note it down. I'm drawing diagram. Please draw in your notes. Right. See, what is the alpha ray scattering experiment means? This is one radioactive substance. What is the radioactive substance? Here, this is radioactive substance. Rough diagram. Radioactive substance. Radioactive substance. So when alpha rays, when this is the X-rays are incident on this radioactive substance. So these are the X-rays. X-rays are incident on radioactive substance. So it releases alpha rays. Releases the alpha rays. These are the alpha rays. Alpha rays. These alpha rays place one grating. So, grating means polarization. What is the meaning of polarization? Means to all radiations, emitted radiations, focused in a particular point, not spreading in all directions. To avoid the spreading, so one grating is placed, right? Okay, take this. Simply you can take this one now. Grating. So what is the purpose? Means the number of alpha particles are emitted from the radioactive substance. They are all focused in a particular path, particular direction. So all these radiations are focused on one gold file. This is the gold file. What I am giving gold color, where are able to listen. See this. This is the gold file. This is gold file. So this gold file is completely surrounded by zinc sulfate, ZNS, zinc sulfide screen. So it is surrounded by zinc sulfide screen. Zinc sulfide screen means it is a photographic platinum. Right. So these radiations are this is a zinc sulfide screen. Right. So when the alpha rays, number of alpha rays are focused on gold file, gold file, it is a very thickness is very less, that is 0.01 only. It's a very thickness. So radiations are like this. Oh, I'm sorry. Yeah.
What is graphing, sir?
Yeah, try to understand this
Yes,
one.
sir.
Right?
Sir.
Yeah. Yes, yes. Yes, tell me. Hello.
Sir.
Hello.
Yes, sir.
Tell me now.
Sir. Yes, sir. Sir, what is this you have written in between grafting or something, sir? This.
What is
Sir, grafting you have written in between, sir. What is that? Starts
grating?
with G.
Grating, not grafting. Grating.
Oh, okay. Okay, sir.
All right. Next. See this. Yeah. What is a grating means? So this is the actually when the radiations, not radioactive substance from radioactive substance, when X-rays are incident on the surface of the radioactive substance, number of alpha particles are emitted. Alpha particles means alpha rays, but the rays are spreading in all directions now. So to avoid that spreading of all directions, that means all radiations make it as in single path. That is the purpose of grating. Now see the observations. So this is the gold file. Next, just observations. You can observe here also a small diagram. Okay, I'm writing here diagram. Same this one now. Here number of radiations. Try to understand this diagram, second diagram, what I am trying now.
So, what does this
Yeah, I will explain that one, please.
diagram represent?
Yeah, listen now. So here, when some many alpha radiations passes through the gold file, right? And see in the second diagram, so those radiations are passes through the gold file and focused on photographic screen. What is a photographic screen? This one is the photographic screen. ZNS.
Zinc sulfate, sir. Zinc sulfate.
ZNS,
Yes, sir,
zinc
zinc
sulfide. This is a photographic.
So, zinc sulfide.
Sulfide, zinc sulfide only, ZNS.
Oh, okay.
Photographic screen.
Okay.
So many of the maximum number of alpha particles passes through gold file and focused on photographic plate. And very few of the radiations are deflected with certain angle. And very few means around about 20,000. For every 20,000, one radiation perfectly reflected back with 180 degrees. So these are the observations in this experiment. From that observations, what he concluded, Rutherford, he concluded as, so it what he concluded means more number of particles are passes through the gold file means in the atom the maximum space is empty. In the atom maximum space is empty, and few of the radiations are deflected with certain angles, means those are near the passes near to the nucleus. Near to the nucleus means some particle at the center. At the center, they are deflected, and very few means 1 about 20,000. It is perfectly rebounds back. So that indicates what is the alpha particle is the positive charge. So that indicates some certain positive charge concentrated at the center of the atom. He named as nucleus. So very few means 1 about 20,000 is perfectly reflected or rebounds back with 180 degrees. So that indicates there is a certain positive sense or positive part is concentrated at the center of the atom, named as nucleus. These are the conclusions. So the nucleus, the size also determined. So the nucleus size is 10 power minus 10 meters. So 10 power minus 15 meters, and radius of the atom also 10 power minus 10 meters. The difference means the nucleus is 10 power 5 times. Yeah.
So what's the size of the nucleus?
The size of the nucleus is 10
So what's
power.
the size of the
The size of the nucleus is 10 power minus 15 meters.
Okay, sir. Okay, sir.
And size of the atom is 10 power 10 minus 10 meters. So nucleus should be 10 power 5 times less than that of atom. And atom is 10 power 5 times greater than that of nucleus. Derived some properties. So based on that, derived the atomic number also. Atomic number, and after that isotopes, nucleids. What are the nucleids and all? Second diagram. So just type that in that file. This is the gold file, contains many atoms now. Shema. In the second diagram, this one. Yeah. This is the gold file. Gold file. In this gold file, many atoms are there now. These are the atoms. In that atoms, based on that, we are to understanding purpose only, I will give the passes and some are reflected. Otherwise, I will need 1 minute. Wait. Second diagram clearly I will give. Many lines means you feel difficult now. I am taking only atom only from that gold file. Only one atom you have to consider. One atom you have to consider. This is one atom from that gold file. Here positive charge. What is given? See this. Passes. Line passes. Passes. It passes. It is a deflected. Right? It is also deflected. Now we can take this exactly. Take this and it is a return bonus. She says exactly come return box here and this. So now I understood. Okay, one atom only considered this gold file, not total gold file. So draw the diagram. I'll give the matter. All of you completed the diagram. Can I write some important points? Hello?
Okay.
Completed a diagram?
Yes, sir.
Now I'm clearing this and I'm writing important points. Note down. Says, okay, Rutherford proposed the atomic model based on alpha scattering experiment. So take now matter a beam of a beam of alpha particles are passed through a thin gold file which is enclosed with fluorescent SCENT fluorescent ZNS zinc sulfide screen capable of producing scintillations. Write the spelling. SCINTILLATIONS. Scintillations. Okay, now observations.
Yes, sir. So what is scintillations?
Scintillation means it is the giving, bright, so blinking of the light. Blinking of the light.
Okay, sir.
Observations and conclusions. Okay, observations and come to the conclusions. Here only can take observations and conclusions. Take no point wise. So most of the alpha particles passes through the file without any deflection. Which indicates that most of the atom is empty. Atom is empty. Next point is a small fraction of alpha particles fraction of alpha particles were deflected deflected from its
So they were
original
reflected at
path.
acute angles, right?
Yeah. Original path, which indicates that the positive charge is at the center of the atom. Center of the atom, and due to repulsive force, deflections takes place. Repulsive force deflection takes place. Next point is, take this. A very few alpha particle, a very few of alpha particles bounced back, which indicates that the whole mass is concentrated at the center, at the center of the atom, at the center of the atom. This heaviest part is named as nucleus. Center of the atom is called as, or is named as nucleus. Nucleus. Okay, all of you understood all that first 3 points. Can I clear this first line?
Yes.
I'm writing 4th point, continuation point here. Yeah. Next continuation point is the radius of the atom is very small, and in the order of 10 power minus 10 meters. Whereas for the nucleus, is 10 power minus 15 meters. And one more last point is there. Right. Next, the electrons revolved around the nucleus. The electrons revolve around the nucleus, like planets revolves around the sun, Hence, this model is called planetary model. Or nuclear model. Okay, next. Another this point. Yeah, next save this one. What are the defects of Rutherford atomic model? Defects of Rutherford atomic model. Defects of or limitations of Rutherford atomic model. Second point, last line. Revolve here, second point. Okay. Next one, defects of Rutherford atomic model. So yes, what are the defects? Are you able to see this color? Look, it is it is against to law of electrodynamics. It is against to law of electrodynamics. Now, what is the meaning of electrode? Is the electron revolves around the nucleus in circular path, continuously loses energy and fall into the nucleus. Then it is that only discussing that. Next, it was failed to explain stability of atom. That means it was failed to explain the stability of atom. Next, not able to understand what this. According to classic electromagnetic theory, according to classical electromagnetic theory, the revolving electron should lose energy continuously. And travel in a spiral path. In a spiral path. So finally, it must fall into the nucleus. But it does not happen. This is a major failure of this. Okay, one more point I'm deleting here.
So,
Only one point I'm deleting. Next point is the atomic spectrum should not continuous. The atomic spectrum should not be continuous. Continuous band spectrum. Due to continuous loss of energy. Loss of energy.
yes, sir. So the atomic spectrum should not be continuous broad spectrum.
Yeah, the atomic spectrum should not be continuous. Okay, comma, should not be continuous, comma, band spectrum due to continuous loss of energy, but it is a line spectrum. One more. Okay, next part, next concept will come, spectrum, we'll discuss that is what is a line spectrum, what is a band spectrum.
So what have you written in the end, sir? But in line spectrum.
But it is a line spectrum.
It is a.
It is.
Okay.
but it is a line spectrum. So generally, atomic spectrum is the line spectrum, molecular spectrum is the band spectrum. But we are thinking about the atom only, right? So it shows the atomic spectrum only. So that will spectrum classifications will come in that case we can discuss. And last point, D minutes. It cannot explain the electronic structure of atom and energies of the electrons. It cannot explain the electronic structure of atom and energies of electrons.
Sir, can you repeat the fourth point?
It cannot explain
So the
the
previous
electronic structure of atom and energy of the electrons. Energy of the electrons. It cannot explain the electronic structure of atom and energy of the electrons. Energy of the electrons.
sir, the fourth point, the previous point.
Last point,
Sir, no, sir, the atomic spectrum should not be continuous.
yeah, not continuous. The band spectrum, due to continuous loss of, the atomic spectrum should not be continuous, and band spectrum also should not continuous due to continuous loss of energy. Yeah, both simply both atomic spectrum and continuous spectrum should not be continuous due to continuous loss of energy. But finally, it shows the line spectrum only. That is also discontinuous spectrum, not continuous spectrum. So at this point, clearly you'll come to know the spectrum definition, and again spectra, classification of spectra, continuous spectra, discontinuous spectra. Again, discontinuous spectra divided into two types: emission spectrum and absorption spectrum. Again, emission spectrum divided into two types: line spectrum, that is line spectrum or atomic spectrum. Another second type, band spectrum or molecular spectrum. That classification will come later. Okay.
Okay, sir.
Understood all?
Yes, sir.
Okay. Can I clear this?
No, sir, 1 minute. Last point.
Yeah, noted.
Okay, sir. So are we doing anything else today?
So just only I will give the definition, one small definition. And I will...
Yes, sir. Yes, sir. Yes, sir.
Okay, you know atomic number. What is atomic number?
So atomic number is the number of protons or electrons.
Oh, sir, you can drop.
Okay. Not only simple definition I am going to. Right.
Sir,
What
finish,
is
sir, you
atomic
can
number
drop.
means the number of electrons or protons present in the atom of the element called as atomic number, right?
Yes, sir.
Yes, sir.
Okay, and mostly give the relation between atomic number Z and frequency of the characteristic properties of X-rays. So what is the mostly relation? So write this point, atomic number. Atomic number. So representation is Z, right? That means number of protons or electrons present in an atom. Is the atomic number, right? That is called as atomic number. And one more. Mostly given the relation between atomic number and the frequency nu,
So what is the okay?
frequency of the characteristic X-rays. In alpha scattering experiment now, the X-rays only incident, right? X-rays of the element by the equation. So what is that one? Root nu is equal to, take this relation, A into Z minus B. This is the Moseley's relation. A and B are the constants. I am writing down this explanation. Here, where A and B are constants. Depend on nature of the elements. Depend on nature of the elements. Next, what is the frequency? Z is the atomic number. We know Z is equal
Yes,
to
sir. Nu is the
atomic
frequency.
number. Nu is the frequency. Okay. You know what is mass number?
So A.
It is the sum of the mass of
Electrons
protons
and neutrons, or protons and neutrons.
Not electrons. Sum of the
So protons and neutrons. Protons and neutrons.
protons and neutrons. That represented as Z.
So no,
Mass
sir, A, no? Mass number is A.
Correct only. Mass number is
Sir,
atomic.
wait, sir. I was writing 1 minute.
Previous page, huh?
Yes, sir.
Sir, can you go back to the previous page 1 second? Okay, sir. Thank you.
Okay, you know atomic number, right?
Sir, don't go front 1 minute.
Atomic mass number, you don't know.
Sir, I know, sir.
Yeah, that is Z.
A, sir, A.
Sir, 1 minute.
Atomic mass.
Sir, 1 minute. Go back, sir.
Oh, already. Okay.
Yes, sir. 1 minute.
Okay, next we'll discuss about next class. We're discussing about the wave nature, wave electromagnetic spectrum, and wave theory. We'll discuss.
Thank you, sir. Thank you.
Characteristic properties of wavelength, frequency, wave number, amplitude, velocity, and based on that, some problems also are there, numericals. So next class we'll go for the wave spectrum and wave theory. So okay, any doubt today class?
No, sir.
No, sir.
Okay, fine. Thank you.
Okay,
Thank
thank you,
you,
sir.
Closing.
Thank you, sir.
Thank you.
Thank you, sir.